So chances is that you may have worked on some of the scenarios from this Excel spreadsheet. So this Excel spreadsheet that I'm presenting now has like 6 different scenarios, 5 in addition to the baseline, which is altogether 6 different scenarios that I wanted to fully present it to you, so that you can have a deeper understanding in terms of how this process analysis works. So eventually, you will be, as a manager, you'll be contemplating with several different process design to see which type of design suits your lead time as well as a cost utilization target. So as you can see that we have like 6 different scenarios, including initial baseline scenario. There's a description for each scenario, and with all those different performance metrics already being calculated here. So it'll be extremely time consuming if we try to do each scenario together step by step in a video recording setting. So what I have done is I'm going to offer you this fully developed Excel spreadsheet as attachment. And in this video, I'm just going to highlight some of the areas where you wanna take a look at again, or think about this again, or maybe take a deeper look again, depending on your analysis needs. So I think this baseline scenario is the initial scenario, highly imbalanced. Right? And in this particular case, we also had this very low demand, which has resulted in actual flow rate lower than the capacity of the process itself. Therefore, it sort of made whole analysis a little bit more tricky. Okay, so in all these subsequent scenarios, I have get rid of the assumption so that basically you have all the motivation or incentives to ramping up your production capacity, because demand is kind of unlimited. You just want your processes to be in a fully functioning mode. So anyway, in this particular case, the one area is utilization, and the other area is time to 1,000 units. And here's the direct cost labor, and then one is the system capacity. I think we're mainly evaluating those 4 different areas. Some of you may feel odd why I included this matrix. So a lot of times in production settings, you produce or you manufacture in batches. So for example, each batch contains 1,000 unit, and then you will ship it to your customer. So it is important for you to know that how long you want to promise to your clients for the batch quantity 1,000. I mean, of course, from the client's perspective, it's the shorter the better. Or and maybe if you know your target shipment date, you kind of know, calculate backward how soon you should start. So that this information therefore can be crucial when it comes to making the actual business decisions. So I think we spent some time look at the baseline scenario, and then I'm moving to the scenario number 1, which is after the line balancing is conducted. I think the only highlight with this particular scenario is that you have regrouped your task so that your cycle time is now much shorter, therefore your capacity is higher. So the resulting matrix, if you look at here, the flow rate is this, and this is the time to produce 1,000 units, depending on what kind of processes it is. We're looking at 185 hours, and average utilization is much better than the baseline scenario, which is at 80% in normal capacity. In this particular scenario with a demand cap, it's going to be 63. But again, this is much higher. Labor cost, I think nothing has changed in terms of number of people you are hiring hasn't changed. So in this case, because we got rid of the demand rate constraint, so this is going to be the direct labor cost in your full capacity. So your saving here is there is a saving of, I can't tell the difference, but there's some amount of saving here. The reason why I don't do direct comparison is because this direct labor cost, it considers the actual flow rate, which is constrained by the demand rate. So I think the actual labor cost in this case is going to be, let me just really real quick. Actual cost of labor per hour is going to be total wages per hour divided by the actual capacity instead of the actual flow rate. So it's going to be $7.92 per unit. Okay, units per USD per unit. Okay, so the beauty of this particular scenario is that you didn't actually do anything. You didn't upgrade your machine. The only thing you did is sort of implemented this managerial idea called line balancing, which resulted in huge savings in your direct labor cost. For the second, third scenarios, they are basically same in a lot of performance matrix. As you can see, in this case, we are replicating the initial balanced production line into 4 different lines. Therefore, your capacity has quadrupled. As a result, a lot of matrix improved, but did it actually improve your cost? In terms of per unit direct labor cost, it did not help much. It's basically identical, right? That's because your capacity is 4 times faster, but at the same time you have hired 4 times more people. Therefore, it has maintained original direct cost level. But how did it help you? The way it helped the scenario 2, the way it helped your processes is that it has significantly reduced amount of production time for each 1,000 unit. So I think that is a significant saving when you compare here with here. So scenario 3, I think because you're looking at a very, very well balanced process, therefore it's basically functioning in a identical performance matrix when you compare to the scenario 2, because by putting 3 more workers, therefore making 4 workers in each step, the capacity of each step is now 4 times higher. Therefore, entire system, the capacity is now 4 times higher, just like this particular system design. So I think I briefly mentioned during the class that then how does it different? I think the only difference is that it has much wider span of control because you need to pay attention to 4 different lines at the same time, where here you are only monitoring 1 line. I think that is some kind of advantage with this particular design. Okay, so again, if you go back to scenario overview, scenario 2 and 3, they're basically identical in a lot of matrix, in all matrix, including utilization rate, process capacity, and time to 1,000 unit, as well as direct labor cost. And then let's move on to the scenario 4. I think in scenario 4, the idea is that you are going to hire 12 people and then make this highly specialized process. And this is how the tasks are assigned or distributed among 12 workers. So as a result, we can imagine that your cycle time is going to be greatly reduced, and of course, in doing so, your capacity is going to be greatly improved. So this is the capacity under this design, and we have much shorter, say, the time to produce 1,000 unit when compared to, and not compared to this one, but compared to the initial very balanced, because this is a way more specialized, way more balanced than the scenario number 1. But if you look at the cost, which is something interesting, even though your capacity has improved, but because of the fact that now you have hired a lot more people, your direct labor cost per unit is actually going to be slightly higher than this particular design. Okay, so this is something interesting about this thing. So I think that scenario number 5 is something I should use this. So in scenario number 5, the last scenario, what you plan to do is actually you're just gonna only keep one worker, let him do all the work. You're gonna beat him to death, right? You're gonna make him work 60 hours per week, but you're gonna pay him really, really well. So for example, regular pay. It's gonna be first 40 hours of each week. It's gonna be the regular pay rate, and after that, up to 20 hours, you will get paid twice much than your regular pay. So you just decided to pay him really, really well, right? So this is a kind of a setting, and as you can see that all the tasks are assigned to this one particular worker. So he's the bottleneck, he's everything. So his utilization rate is gonna be very, very high, 100%. So it's fairly straightforward. But at the same time, the capacity, as you can imagine, is going to be super low. It's almost 2 units per hour, not quite there. It's 1.9 unit per hour. So as a result, you can imagine the time to produce 1,000 unit is going to be very, very limited. It's going to be very, very long. It's going to be almost 10 times longer than all other scenarios where it involves more workers. But the beauty of this design is that you're going to have a much lower direct labor cost. I think it's going to be the lowest among all different scenarios. So if you go back here, this kind of summarizes everything that we did. Let's see. So the cheapest process design is one worker scenario, right? The most expensive design is our initial baseline scenario, where you have highly imbalanced line with the 3 workers, right? So again, scenario number 1 is basically improve the scenario with much balanced design. So this is amount of cost saving, but this one uses, right, after that, it's gonna be hiring more people to ramp up the production. So which one is the best? Well, I think this really resembles like a real world analysis where you don't have a clear winner in many ways, but it depending on what is critical, right? What is critical in your business? If to you the lead time, right, the time to make each batch is really the critical, and the direct labor cost is a somewhat flexible, I think you'll be looking into this criteria with a greater weight, right? You're going to put more weight in this decision criteria. But if you're just solely, focused on cost saving, maybe you want to consider this approach, or maybe slight variation of this approach. Well, this is not the end of this analysis. You can keep expanding, or you can keep exploring different variations of this process to be able to meet your analytical needs. So I think I can conclude this video. I'm going to attach this Excel spreadsheet so that you can take a look at this yourself. If you found any errors or mistakes, more than welcome to send me a message. Thank you.